The age and design of the bridge made it vulnerable to damage from a truck strike.
Hit just in the right spot, that portion of the bridge simply folded up. King 5's Glenn Farley first brought you the likely cause of the collapse last night and has a lot more, and you've brought along an example.
I have brought along some visual aids here. So the bridge over the Skagit River is called a truss bridge. There are various types of truss bridges. This is another type of truss bridge. It's different, but the principle is the same. So I want you to pay close attention to two things. The lower cord here, which is at the bottom of the bridge, this is being pulled. It's under what's called tension. Then the upper cord up here is being compressed. And as long as those two are in balance, the bridge is fine, it stays up. But if either one of those is damaged or cut through, then we've got a problem. The nearly 60-year-old bridge is not considered structurally deficient, meaning there's no corrosion problems and it's not considered unsafe. But bridge building designs and standards were different in 1955, and it was vulnerable to a well-placed strike by an oversized load.
We have a national infrastructure problem.
Jeffrey Berman is an associate professor of civil engineering at the UW, an expert in steel truss bridges. He says a more modern design would have been more resistant to collapse.
We are vulnerable to collapse if the right element or set of elements are damaged.
The truck hit several of these archways that hang low along the side of the bridge, catching the corner of that oversized load.
It's bracing the two top cords of the truss to each other.
As the oversized load rolls onto the bridge at highway speeds, the corner catches on one of the first arches. Since the arch is attached to the upper cords of the bridge, that critical compression part, there's a problem. The exact sequence of which parts failed and in what order may not be known for months, but the bottom line is, without that upper cord, the bridge folds up and lands in the river.
We certainly need investment.
It becomes a question of priorities, says Berman, with a long list of bridges that could use some help.
This will certainly raise awareness for a little while,
okay,
and we'll see if it sticks.
Despite the vulnerabilities, the odds of this happening pretty remote. Remember, this bridge has handled truck traffic since the mid-1950s, including, of course, I think we can safely assume, a lot of oversized loads. I mean, this is traffic central for commerce.
And you have a number of sections. Those sections, the steel structures, are not connected.
So we think of it as the bridge.
Right.
But the reality is it's a bunch of bridges all together. So if you take our model here, you got another one next to it. So unless you lose the pier, which is holding up the ends of both of those bridges, so you can lose one and not lose all of them.
Okay. Right. Thanks so much, Glenn.